back. Today we'll be covering one of the most promising companies that might change the way we actually communicate in the future. Let's go. Neuralink is a company founded by Elon Musk, with Max Hodak as its president, back in 2016. Elon Musk, as you might know, is also the founder of companies like Tesla, SpaceX, OpenAI, and The Boring Company. Back in 2019, Elon and his team gave a presentation about the company's goals and what it hopes to achieve in the coming years, and the suggestions by the company of what it might accomplish are quite astonishing. Neuralink, as stated by the company, ultimately aims to develop ultra-high bandwidth brain-machine interfaces to connect humans and computers. The company hopes it will be able to solve brain disorders and brain damage, and enhance our ability to interact with computers and technology in general. To give you a bit of context, we'll start with a small explanation of what neurons are briefly. Neurons are the fundamental units for our brains and nervous system. They are of many kinds and shapes, but they're generally made up of three parts: dendrites, the cell body, and the axon. These neurons connect to form a network in our brain. The network uses action potentials, which are electric signals, or hikes as shown, in order to communicate and send or receive signals, which is basically an input-output methodology. As a basic principle, it is assumed that neurons represent information as spikes that we see on our monitors. These signals produced form an electric field around the neuron. This is what we want to detect by placing the electrodes, which, by the way, is 1/10 the size of the cross-sectional area of a human hair. The threads coming out of the electrodes are aimed to be about the same size of the neurons. Everything we hear, feel, think, or even perceive are action potentials and electric signals in our brains, so we can virtually understand anything with enough information and enough data. When we do collect the information needed from these neurons, we can then feed the algorithms in our computers the data in order to recognize some sort of pattern with a specific correlated movement. At least that's the plan. This will help us map different movements with different signals and use them to understand and treat different cases. A potential scenario, for example, is understanding what a hand movement command looks like in our brain. Map that to the patients, help them get configured with that command, and eventually they'll be able to move a robotic hand just by thinking about it, or scroll their Instagram feed just by thinking about the gesture. But how does this compare to what we actually do in real life? At the end of the day, this is all theoretical. Well, not quite. See, brain-machine interfaces, or BMIs, have existed in research for decades. Deep brain stimulation, or DBS for example, is used nowadays to treat people with Parkinson's, and it has existed since 1997, which is quite a long time. The process takes around 5 hours to do, and has only 10 electrodes. The electrodes have also limited capacity of catching the signals that we want, because of their count and because of their size. And overall, the procedure is riskier. When we look at past research and methodologies, even though human trials have been followed through in the past, two big problems still arise: low bandwidth, high invasiveness. So when we talk about low bandwidth, we have billions of neurons, but BMIs only record a few neurons at any given time. This makes using them for any high fidelity system difficult. As for high invasiveness, the implant requires neurosurgery and a constant hardwired link into the brain. This means that it is restricted to people with a massive need to do this, as the hardwired link increases the chance, unfortunately, of brain infection. Neuralink seeks to solve this in the short term. The company wants to build a high bandwidth, minimally invasive BMI that will be FDA approved, so it can start to use in real-life patients within a few years. The Neuralink robot, in comparison, inserts the threads very accurately, bypassing any blood vessel, trying to minimize any risk of trauma or internal bleeding in the brain, and can manage, allegedly, thousands of electrodes in comparison, with minimum effort as everything is automated. The BMI will be via Bluetooth, so no wires will be coming out of your head. Instead, 4 N1 sensors will be placed, connecting through small wires under your scalp with an inductive coil behind your ear. That connects wirelessly with a wearable device called the Link, which contains Bluetooth radio and a battery. And if that is removed, everything is shut off. This, I believe, is easier for software and firmware improvements in case the person wants to upgrade something, and it is safer as it's wireless. All of this, surprise surprise, will be connected to your iPhone using an app, things that have been taken for granted nowadays with such technological advancements. And by no means is this a mandatory process. People can choose to do this at their own will and risk. The company in 2019 hoped to achieve this whole thing in a human brain by the end of the year 2020, but by the way things are going with the coronavirus, the progress is bound to have been slowed down, especially given the fact that every single step the company tries to do needs FDA approval first for its safety and human trial purposes, so none of Neuralink's methods can be tested on humans until they are approved. However, Elon announced on Twitter last week that there will be a Neuralink update on August 28th of this year, which is very exciting news, knowing that the team might have had some progress in light of the worldwide situation and setbacks. So what are the implications on the healthcare industry? Well, in general, it has the potential to help people suffering from strokes, neurodegeneration, cancer, spinal cord injuries, and many other healthcare issues. These conditions affect millions of people each year and also cost the healthcare industry millions to treat. If the company project proves to be successful, years of expensive treatment and therapy and many risky injuries could be replaced with a simple, microscopic brain implant. So thank you everyone for watching. I hope this has been an informative video for you. If you enjoyed the video, please hit the like button, comment below. I'd love to know what are your thoughts on this new technology and where do you think we're going. In any case, please subscribe to the channel for more informative videos. Catch you later.